internet if you're interested in more precise average. So, of course, there are a number of you who score above 90, so I'm going to count those students who got above 90 and 100.
You get my pizza?
What is that?
Pizza?
No. Okay.
You should be proud of us.
Only these students maybe they deserve pizza, but there's too many of them. So Penjiang, anybody? Okay. Yu Ping Li. Jia Shi.
Here.
Wan Dan Guo. Mazin Bokhari. Xiao Chu Liu. Zhao Feng. These are the ones who go to the Ying Wang? Ying Wang? No? Not here. Na Yong Li? Xiao Yuan Zhang? Xiao Yuan Zhang? Andrew Weiner? Andrew Weiner? Eric Delanois? Eric Delanois? Ying Qiu Li? Yi Juan Yang? Zhao Liu Qing? Yi Hua Gan? No, not here. King Wong. King Wong. Chen Zhang. Xian Zhang. Okay, the rest are below 90, so I just hand them back to you. Okay, just pass it around. Is that okay with you? Let me pass it around. So, Nitya, how did they hand out exams in the past? Do they pass it around?
I don't know.
Okay. If you're worrying about your privacy, we can put the exam somewhere. You can go to the room and collect it. Okay.
Yeah, I think that's better.
Huh?
I think that's better.
It's better? Yeah. I should collect them and then put it in the room and you go and collect your exam. Okay, I think that would be better.
Or if they want it, I can keep it in my office. They can come and collect it.
Oh, you can go and collect from Aditya. Okay? Then you have a little bit more privacy.
Yeah.
Do you mind if I can't stay for this lecture? I'm going to come back for a different professor's lecture.
Come to my office.
I'm going to the other professor's lecture after this and going to like review the exam, then I just can't do it this lecture, you know?
So I'm supposed to give an exam review today. So I'll review the questions in the exam. Okay? So you score 100, you can leave the classroom.
So
You don't need to review it, right? What do you think? According to my schedule, I'm supposed to do exam 1 review today. Am I right? Right? So I suppose I'm supposed to do that.
Just where are you going to transfer this out?
You want to
Use
teach,
us.
you want to learn Fourier transform?
Yeah.
Oh, okay. That's a little bit too difficult.
What does it say?
So let's do exam 1 review, problem 1.
So what do you want? So let him review and I read out the exam. I read out the names to do that. Professor, some of them want their exams while you're reviewing.
Oh, then
So you can review and I can maybe help them pass it around.
okay, that will take a while to pass around the classroom.
No, I'll read out names of code and you can continue reviewing the exam.
Okay, you read out their names.
Yeah.
Okay, that's fine. You listen to Aditya when he reads out the names. Okay, then you collect the paper.
Andrew Nicholson. Andrew Doyen. Andrew Doyen. Ben Cheslaw Kratz. Nathan Davis. Who's Nathan Davis? Jake Byrne. Tim Clausen.
Right here.
Tim Clausen. Patrick Van Vanwell. Who's Patrick Vanwell?
So you're given that the resistor absorbs 3 watts. So figure out what R is. This is quite simple. Okay. The power of the resistor
Who's Edward
is
Husserl? James
I
Howard?
through the resistor times the R of the resistor, but I through the resistor must be 3 amps
Who's James Howard?
times R, and this is given to be 3 watts.
Hugh Chan Hunt?
Let me
Who's
see.
Hugh
Is this
Chan Hunt?
I square R, that's right, I square R. So this is 3 watts. Okay, I square R is equal to 3 watts. So R must be 1/3 of a watt. Okay, that's part 1 of A. And then you're supposed to figure out this voltage, V. You're supposed to figure out the
Kylie Petlak?
node
Rebecca
voltage
Freeman?
V1. Okay, you're supposed to figure out what V1
Who's
should
Rebecca
be.
Freeman?
So V1 is just I times
Gillam?
I times
Alexander?
R plus 2. R is actually ohm, so 1/3 of an ohm, sorry. So if you have this R plus 2, then you have 3 amps. I is 3 amps times R plus 2, which is 2 1/3.
Robert Master?
Okay. 2 1/3, and then this
Who's
is 7
Robert
over
Master?
3 is 7 volts. Okay, 1A is 7 volts.
What's your name?
And then 1B,
Jimmy Tippett? Jimmy Tippett?
1B you're given a different circuit.
Jerome Lawrence Anderson? Titus form?
Given that this is 2 amps,
Who's Titus form?
and then you're asked to figure out what Vs is and what P sub S is. Okay? And you are given that this current source
Nick Wheeler?
absorbs 6 watts.
David Wu? David Wu?
Okay, given that that current source absorbs 6 watts. So if it absorbs 6 watts, that means that there is a voltage
Samuel Homer?
that is in this direction that together with the 2 amps
Michelle
give you
Erickson?
6 watts. If I call this voltage
Michelle Erickson?
voltage through the current source,
Andrew
then
Curtis?
voltage through the current source times 2M must be equal to 6 watts. So the voltage through the current source must be equal to 3 volts.
Tyler Ward?
Okay, there's a voltage drop of going like this in this direction in order for this to absorb 6 watts, okay? So it's almost behaving like a resistor in a sense. So Vs must be equal to minus 3 volts. Okay, Vs is just opposite of DC. Okay? And then you're supposed to figure out P to the source, which is Is Vs. Is is going to be this current flowing in that direction, but this current will split itself into two.
Adam uses.
Okay, this current will split itself into two. You're given that this is 4 ohms.
Uiuc.
Okay, you're given that that is 4 ohms,
Lower Prince.
but Vs is minus 3 volts, so there must be a current I resistor must be Vs over 4 ohms, which is minus 3 over 4 M. So there must be a 3/4 M going down here with a negative sign, which means that it's actually a current that flows in that direction. So you can figure out what Is should be. Is should be equal to 2 amps plus 3/4 amps, which is 11 over 4 amps. Okay, I think that's correct, yes. 11 over 4 amps. So there's an Is flowing this direction, which is 11 over 4. And then this is counter to the voltage direction. So this must be a power absorbed by the source. Okay, that must be the power. Ps is Is times Vs, which is minus 3 volts times 11 over 4, which is 33 over 4 watts. Okay, so the voltage source is given out minus wattage. That means it's given out sources, given out energy, given out power, instead of absorbing power. That's what it means. Okay. And then part C. Part C, you're asked to simplify this complex number. J to the power of 6. Okay, you're asked to simplify this number.
Adrian Leo.
Okay, there's a,
Michael Kwan.
you can convert this to polar.
Michael Kwan.
There's one way to do that.
Ashley
But
Williams.
then there's the clever student who did something else. Okay, instead of converting to polar, he noticed something. Okay, if you were to square this, you get 1
Brett
minus 1
Keller.
plus
Brett Keller.
2j, right? You get this number. So you get a pure imaginary number. So then you can figure out 1 plus j cubed is equal to 2j cubed, right? This will be 8.
Emily Turner.
Yes? Okay, minus 8j, right?
Raymond Roberts.
So you can actually find, no. 1 plus j 6.
J.
1 plus j6 is 2j cubed. Okay, because 1 plus j6
Bonathan.
is 1 plus j squared, the whole thing cubed.
Aaron Smith.
Okay, so you can write 1 plus j to the power of 6 is 2j cubed, which is just minus 8j. Okay, so this is just minus 8j. And then z would be equal to 2
Lee Chun Chan.
minus 2j.
Lee Chun Chan. Yishwan Zhang.
Okay, so you can actually figure out the magnitude of this, which is what you're asked to find, which is square root of 4 plus 4,
Who's Andrew Doyen?
which is
Andrew Doyen.
4 times 2,
Nathan Davis.
which is 2 root 2. Okay, so the magnitude of z is given to be that. And then what about the angle? This is right at 45 degrees.
Patrick Van Werven.
Pi over 4, okay, minus 45 degrees. So the angle
James
is
Howard.
minus pi over 4,
Hugh Chan.
okay, minus pi over 4,
Rebecca Freeman.
okay. So this is problem number 1.
Robert Maston. Jimmy Tiffin.
Are there any questions so far?
Vitus Fong. Nick Wheeler.
If there are no questions, then we, yes.
Where would we go to find out more directly what's going to be on this? Because I guess I wasn't prepared for imaginary numbers, and I didn't see it on any of the previous tests. I guess if you go back far enough, they are on test before 2011, but after that, there were not imaginary numbers on test.
So there were no complex numbers on the previous test.
That's correct.
Is that what you meant?
And other classes were told that they needed to study for imaginary numbers, and either I missed that or we weren't. And I just would like to avoid that.
Oh, okay, let me point that out to the chief instructor then, because she controls all the exam problems. And this is actually part of the syllabi, part of the syllabus.
And I know that we did it in a review and it was part of the first homework. It's just that in reviewing for the test, it wasn't on the previous test, so this isn't material that I covered.
Okay, let me convey your concern to the instructor, the chief instructor. Okay, and see what she says. Okay. Any other questions? Okay, if there are no questions, let's go to problem 2.
Thomas?
You have a question, anybody?
Thomas, what? Yeah.
Problem 2. And this again has 3 parts. Okay? You're asked to find some constants. Of this surface. You have Vs, you have Is, you have 1 ohm, you have a current I that flows here, and then you have a voltage control, a dependent voltage source, okay? And then you have 3 ohms here. Let's call this X. You can solve this problem by the node voltage method or the loop current method. I prefer the node voltage method because I think it's simpler. What is that? You can also use principle linear superposition. Turn off a source and then turn on one source and then turn off one source and then turn off the other source. But I think that's slow because you need to solve 2 problems. You can do it fast? Okay, let me give you the solution here, which is quite fast. Maybe yours is even faster, I don't know. But you can solve this as one entire problem in one go, and then get the 2 constants. You're supposed to find K1 Vs plus K2 Is. Okay, you're supposed to find K1, K2. You can use the principle of linear superposition to solve 2 problems, or you can just solve this problem in one go. Okay? Maybe you can do it with 2 problems and solve it in 2 goes. Okay? But first, write down KCL at this node. KCL at that node will give you X minus 2I. Okay, this is X. The instructor just put X. Okay, actually it stands for a voltage. Okay, the current divided by 3 gives me the current that flows in this direction. Okay, and that current minus this current, okay, minus this current, plus the other current, which is the current that flows in this other direction. Okay, let me call this I right and I left. Okay, this is I right, and then I left will be X minus Vs over 1 ohm. Okay, this is KCL at that node, and this is I left. And this is I down. Okay, this is I down. This I can call right, I can call left, and this all should add up to 0. Okay? But then I have another equation that I need to formulate because I have 2 unknowns in this problem. My 2 unknowns are X and I, so I need one more equation. Okay, the other equation says that Vs minus X over 1 is equal to I. Okay, Vx minus X over 1 is equal to I. It's actually this part of the equation. Vs minus X divided by 1 ohm is equal to I. Okay? And then you have another equation that says that so you have two equations and two unknowns. You can solve for them. Okay, two equations and two unknowns, and then you plug them in. Okay, you plug that into this equation, and you will obtain the fact that x can be eliminated. Okay, you can have x is equal to Vs minus I. Okay, you can plug that in to the above equation and solve for your I directly in terms of your two sources. Okay. So if you want to go through the algebra, then the algebra goes something like that. That you have Vs minus I minus 2I over 3. Let me not go through the algebra. I presume that you have two equations, two unknowns. You eliminate one of the unknowns from the first equation, then you solve I in terms of IS and IR, and then you will get this equation. Okay? And then you get the two constants. So you get the two constants K1 and K2 in one go. Okay, you can also use the principle of linear superposition. Okay. Yes?
So is there no partial credit?
There should be partial credit, yeah. If you do it partially right, if you're on the right track, there should be partial credit.
So like for example, like I had all the equations and the math just went out wrong and I got 0 points.
Oh, then you should ask for partial credit. I don't know who grade number 2. Who grade number 2? Let me see. Tanggu Basar, Professor Tanggu Basar, grade number 2. Okay, you should for regrade. Don't write on your exam paper. Write on a separate sheet of paper and explain to the grader, the instructor, as to why you should get partial credit. And then you hand in that sheet of paper together with your exam book. And do that before Friday. Okay, the last day to hand in your request for partial grades or regrades is this Friday. Okay? Okay, if you want to ask for regrade, do it before this Friday. Let's do part B then. Part B. Let's see how part B goes. Okay. Part B, you are supposed to find Vx in the following circuit. It looks almost like that one, but with some distortion. You have 6 ohms here. You have 2 ohms. You have I going here. And then you have Vx. You have 6 volts here. You have 8 volts here. And then you have 3 ohms here. Okay, you are asked to find what Vx is. What should Vx be? Again, you can use the node voltage method. You write down the KCL at this node. Okay, KCL will give you the fact that Vx minus 6. Okay, Vx minus 6, which is the voltage drop across this one, must be equal to I down. Okay, this must be I down. The current is going downward. Let me call ID or ID. Okay, that current is just Vx minus 6 divided by 3 ohms. Okay? And then you have the other one, which is Vx minus 6I. Vx minus this voltage divided by 6. This will be your IR, I to the right hand side. Okay, and then you have another current that flows to the left hand side. Okay, if I call this current I left, the last term should be Vx minus 8 divided by 2, and all this should add up to 0. That is KCL. Okay? And then you have another relationship that this I, okay, is actually equal to, that I is equal to 8 minus Vx over 2. Okay? This 8 volts minus Vx divided by 2 gives me the I. The I is what goes into this voltage source, the control or this current control voltage source or the dependent voltage source. Okay, so you have two equations and two unknowns. Okay, two equations and two unknowns. And you're very careful with that. You should be able to solve them for the two unknowns. Okay? So, you want me to solve them, or it's okay? That all of you should be able to hack this one, right? Two equations, two unknowns, yes? The answer is that Vx, if I just hack this one first, okay, if I plug this in to the above, I should get Vx minus I is equal to 4 plus 2. Sorry. If I just hack this one, simplify this equation. Okay, if I just simplify it, I get this rather simple looking equation. Okay. Now if I plug this in, this is just 4 minus Vx over 2. Okay. Now if I plug this part in there, I get Vx minus 4 plus Vx over 2 is equal to 6. And then if you solve for that, you get 3 Vx over 2 equals to 10. Vx is equal to 20 over 3. Okay, Vx is 20 over 3. So if you go through the algebra correctly, that should be the case. And then part C, let me see what it does. Part C asks you to use the loop current method to solve the circuit problem. You can actually solve all of them using the loop current method, but Part C in particular asks you to use the loop current method to find the solution. Okay, so I have I1, I have I2 going this loop, I have 2 ohms here, I have 2 ohms here, and then I have 3 ohms on the middle branch. Okay? So it's quite clear that I1 must be 2 amps. There's no change about that. The current source is an immutable source. It has to produce I1 that is 2 amps. And then now you do a Kirchhoff voltage law. Okay, in current loop method you use Kirchhoff voltage law. Okay, so you have the current going through this central branch. Okay, I central must be equal to I2 minus I1. Okay, must be equal to I2 minus 2. The current that's going up there centrally is I2 minus 2. And then if you write down Kirchhoff voltage law for this loop, you have I2 minus 2 times 3 ohms plus 2I2, which is the voltage across this resistor, and then minus 2 volts must be equal to 0 because this is the voltage right. Okay, you have this, and then you can solve for your I2. I2 is equal to 8 over 5 amps. Okay, that's part C. Okay, the current loop method. Any questions on problem 2? Yes?
Why is it I2 minus 2 and not the other way around? Why is it not I1 minus I2? Like, how do you determine which way it is?
Oh, I'm defining IC to be going upward.
Okay. So you can define it IC going the other way?
You can define IC to be going downward, and then you have to put a minus sign. Okay, and then when you write your KVL, you have to go according to the sign of the current. Okay, this current gives you a voltage drop in this direction. If it's going downward, it gives a voltage drop in that other direction. And you have to define the signs of your voltages correctly according to the signs of your current. Everything will turn out to be correct. Okay? Okay, any other questions? Okay, then let's look at problem 3. Problem 3 has only 2 parts. It's my problem. Okay, after I've given the problem, one of the TAs came and asked me, why do I give such simple problem? Okay, hopefully it's not too simple for you. Problem 3. Problem 3, part A, I think is from your homework, except that you have some numbers changed. You can solve this problem using the test current method. You can also solve this as a full circuit problem. And then you have A, B. Okay, you have 3 ohms here. You have 2 ohms here. You have a current source that is dependent on Ix, and Ix is given to be this. Okay? And then, in order to find I Norton, V Thevenin, R Thevenin, and then P available, okay? These 3 are indispensable. In order to find RT, you need one of these 2. Okay? So, I Norton is just I short circuit. V Thevenin is just V open circuit. Okay, so we can find V open circuit first. It's quite easy to figure out what it should be. And if this is open circuit, this current must be equal to each other. Okay, so I have Ix must be equal to minus 2 Ix. Okay, if this is open circuit, no current flows into this direction. So that this current must go in a circle. Then if this current must go in a circle, then at this KCL, Kirchhoff current law, then no, this must be true. This is not possible, so Ix must be 0. Okay, Ix must be 0 when you have an open circuit. So if Ix is 0, then V open circuit is 3 volts. So V Thevenin is just 3 volts. Okay. Then the next thing you need to do is to find IN. IN is a short circuit current. There are 2 ways you can find IN. One is to solve this problem in total. The other one is to use the test current method to find RT, and then from RT you can find IN. Okay? So which method do you want to use? Test signal method, yes?
Sorry, quick question. Could you explain again why Ix is equal to 0?
Oh, Ix is equal to 0 because this equation, if this is open circuit, this I has to be 0. With this I is 0, this current must go in that direction. By Kirchhoff current law, this current must be equal to this current. This current equals that current. And that is not possible unless Ix is equal to 0. This equation cannot be satisfied except for Ix being 0. Okay? Or you can move everything to the left-hand side and say 3Ix is equal to 0. Ix is equal to 0. And this is another way you can show that Ix is equal to 0. Okay? So Ix is equal to 0, that open circuit voltage must be just 3 volts. Then you can find RT using 2 methods. One is using the test signal method. The other one is just to solve this problem in full. Which method do you want to use? Test signal. Okay, he asked for test signal method. So let's see how we do it by test signal method. In the test signal method, you will turn off the voltage source and replace it with a short circuit. And then you put in a test signal. maybe a 1 amp current source. Okay, and then look for what this voltage should be. Okay, so this is Ix, and this is 1 amp going that direction. Okay, if you hook the voltage source there, so you have the fact that if you write KCL at this node over here, you write KCL at this node over here must be Ix plus 1 minus 2I plus 2Ix must be equal to 0. Okay, this current going to that node plus this current going to that node going to that node is opposite of this current. So you have this one plus this one plus this one. Then 3Ix is equal to minus 1. Ix must be minus 1/3. Okay, if Ix is minus 1/3, then what is the voltage? Okay, so this is 1/3. So let me see what this resistor was. This is 2 ohms, this is 3 ohms. Okay, so you can figure out this voltage from the ground. Okay, so V must be equal to minus 2 times Ix plus 3 times 1 amp. Okay, 3 times 1. Okay, Ix is 1/3. So this is 2/3 plus 3. Okay, so it is 7/3, right? 7/3. Did I get it right?
3 times 3 is 9, so it's 11. Oh no, is it negative? No, it should be positive, right? Because Ix is negative.
Ix is negative, you're right. Ix is negative, so I get a positive over here. So it's 11/3. Okay, 11/3 here. And then I would have R Thevenin would be equal to V over I. I is 1.